I've been interfacing with Queen Mary over the last 3 years and going on some of the journey of assignment. The reason that I'm excited today is that the most important thing in life is to get your timing right, and I don't think there's any better timing for UK and Queen Mary as a substantial academic player within the UK to really get hold of its skills and capabilities and see how we can together transform medicine. Now, you're only going to get one slide from me. I hate having to watch 38 PowerPoints coming across very quickly. But the slide is very impactful, and I'm going to talk to you about why I'm excited, because I think we really are on a new threshold of a new lexicon of medicine, and you are right at the heart of it. If academic and clinical science gets it wrong, we're going to wait at least 50 years more than we should have done in terms of moving this into the clinic. And so, as we embrace how medicine has moved on, and I'll explain to you why I believe it's moved on and why you have the timing right, I think this is a great opportunity for Queen Mary's, for the UK, to really play its hand in the translation of technology into redefining, in healthcare terms, the quality of life, whilst achieving greater affordability of healthcare and grasping the opportunity of the translation agenda also creating an economic impact. When I was a kid, we were just finding out that we were no longer the workshop of the world. We'd lost our empire, and we were wondering actually what was our place in terms of a globalizing world. I think there's a very clear place for us in the new world. We have 4 of the top 20 universities in the world, and more importantly, there's a development of the culture of the United Kingdom for a much greater partnership to see how we take technology into the service of humankind and really create societal benefit. Now, let me talk to you briefly about these individuals. Top left is William Castell, the great Canadian who, whilst he was at Oxford, introduced the first discipline of rigorous physical examination and communication with the patient in terms of the diagnostic approach and creating what was then a new taxonomy of medicine. And the bedside manner today is still very much along those lines. What I'm concerned about is I look at all the technologies we've got, whether it's the scanning technology, whether it's the genetic predisposition. How do we stream the information to the physician that allows him to embrace where our technology's got to today? So when he's looking at the patient, he's informed by evidence-based medicine that allows him to grasp personalised medicine and apply it to the patient. So Osler in 1915 introduced the discipline of rigorous physical examination, which exists still around the world. Since Osler, we've seen extraordinary changes, and I chair the Wellcome Trust. Henry Wellcome, on Osler's right, was an extraordinary man that understood the power of marketing, but understood the power of great academic research. He recruited Henry Dale, and in the period 1910 to 1920, the Wellcome Foundation, a commercial firm, had 18 Fellows of the Royal Society. Henry Dale later went on to be the President of the Royal Society, gained a Nobel Prize, and was Chairman of the Wellcome Trust from 1936, when it was established under the will of Wellcome, until 1960. And I had no problem. I was a young employee for 20 years in the Wellcome Foundation. Research was our only shareholder, and yet we learned how to commercialise that. But things have moved on. And so we have Crick, Watson, and Franklin. Franklin didn't get a Nobel Prize. Great shame. But we've seen how this work of Crick and Watson has underpinned modern genetics. And yet, come back to getting your timing right. I remember talking with Glaxo 20 years ago where they were investing heavily in genetics, but it was too soon. And so they had to change their research approach, change their investment in genetics, because we just didn't have the power of understanding of what will be the scale of importance of genetic understanding, where would epigenetics take us, how would we use this knowledge to advantage. The next man up there is a great pharmacologist. I'm on the bottom level now. This is Jimmy Black. Jim trained up in Scotland. He was a great physiologist. He developed pharmacology. He went into agonists and antagonists and really did an extraordinary job in developing drugs which were entirely needed by ourselves, beta blockers, H2 antagonists to deal with the expression of acid in the gut. Jim started to let us really understand how a disciplined research based on biology and physiology and pharmacology could really drive pharmaceutical discovery. And then the last man on the right there, again, another Nobel Prize winner, Peter Mansfield, who was a man who brought nuclear magnetic resonance, an extraordinary foundation in how we look within the body, how we understand the physiology, how we understand the forebear of where we can go today, which is to look with some skills now, we can look at metabolism of carbon in a single cell in the brain, and that's quite an extraordinary change to embrace. So we're on the threshold of having the ability to go for personalized medicine, and that has been bringing imaging technology, molecular biology, genetics, and computing, and adding those to the raft of technologies which were available certainly to the Black and the Peter Mansfield. With those technologies, we have the opportunity, and I'm going to go for it here, of redefining the quality of life. I do think that we've sought longevity often to the detriment of dignity, and to, we all have to come to an end. Let's do it in a quality way, not where we think the longevity is the maximum benefit to humankind. We know we can't afford our healthcare system today. We've got this extraordinary challenge. How do we deal with personalised medicine and take it into a healthcare system that can't even deal with the routine formula for the routine patient? So you fall into that routine diagnostic discipline. And then I feel that there is a chance, and there's a chance because of the way the world's developing, that we can actually use the translation of our great academic capabilities into not only unmet clinical need, but we can take it in to have a much greater economic impact. And the two things here that are fundamental is that the web has changed how you can get your knowledge across the world, your brand, your innovation. And on the other side, the great pharmaceutical firms found that with individual silos reporting to the R&D director, they didn't get the level of productivity that was needed, and they've had to change their model. And increasingly you find them in open innovation, where they will sponsor small groups led biology to find a new therapy, a new diagnostic, and a new immunoprophylactic. So I believe that we are on the threshold of a new lexicon of medicine. I'm passionate that I say to my colleagues, just envision how you will get that data to the general physician. Or we're going to change general practice and go to a specialised physician. And then imagine how you're going to embrace that in medical schools to teach it to the young doctors, so that sometime in their career, in the next 5 to 20 years, they say, oh yes, I was waiting for this, I'm excited, and I'm prepared to go out there and get retrained to introduce it. And the winners in terms of the technological skill and the economic impact will be the winners that have early adoption of these new technologies within their clinical systems. And they will be the winners not only in terms of the cost of healthcare, but they will be the winners in terms of the transformation of the quality of life, and they will be the winners that create the economic necessity for the United Kingdom. So, in the new lexicon of medicine, I do believe we have already proven that genetics can have profound impact on cancer therapy. It can have profound impact on the diagnosis and greater understanding of rare genetic disease. We've seen the whole process of epigenetics developing, and we're seeing epigenetic diagnostics and epigenetics going into clinical application. I've been talking recently to the chief executive of ARM. ARM design in the United Kingdom, most of the chips that you'll find in each of your iPads and your telephones today. So they've had the design skills in the UK, they've been manufactured normally in Korea. He tells me that he can now develop a chip which is thinner than a hair that can be implanted for life into the body and will, because it's so small, it will be able to detect all our life signs, but at the same time be run by the temperature gradient within the body, and therefore he doesn't have to recharge it. Now, that to me is the most amazing and exciting vision, and I'm looking forward to hearing from the Life Science Campus in 3 years' time that you're actually in it and dealing with it. Now, all of these new technologies, as we move to personalised healthcare, we deal with, to the extent that genetics is relevant in terms of predisposition, there are ethical issues on the way. And there's no doubt that as we use technology, not only to improve healthcare, but to underwrite human sustainability and the sustainability of the globe, we have to embrace the humanities. If we don't take behavioural change with us, we don't have a chance. And so I'm thrilled to see a vision of life sciences which embraces the humanities in this great university, because it's with that working together on understanding, creating the trust, creating the communication, that we will be able to take the technology at an early date into practical use. Genetically modified plants is an extraordinary debate in Europe. It's a debate that is over in many other parts of the world. I was listening to the head of CSIRO in Australia recently, advising me as how they've sorted out shrimp farming in Australia, and they're taking their technologies to China and into the Philippines. We need the humanities to help us, the world of science, create the trust, create the communication, create the transparency that allows us to evolve new technologies which will underpin the sheer volume of Homo sapiens that we have on the globe today. Now, I'd like to move on and talk a little bit about more about these partnerships. Universities have a great opportunity. When we look at the interdisciplinarity of innovation today, it goes beyond having a great biologist and maybe a biochemist. It brings in computing and physics, as well as the humanities. And so we've got to the stage where very few industrial companies can afford the breadth of excellence within the functional disciplines that truly allow them to converge the technologies that are now required for innovation. And so the universities are now in a great shape to be not only the source of academia, but also the knowledge hub, where they should be working cheek by jowl to look at innovation, put their teams together, and dream up the new products. I had a meeting about 6 months ago. I had the head of a satellite firm in the UK with the head of Aston Martin. I said, let's just have an hour talking about how you use your skills to control the human body, or at least monitor it. Fascinating debate. They were fascinated. And I have no doubt that as we bring the converging technologies together, we can apply them in other silos, which allow us to increase the scope of our imagination for innovation. Government has a key role. We need to embrace how we change the risk-reward ratio. We've got to the stage now where you couldn't license an aspirin for use. So you have to have clarity of absolute efficacy and no balance with safety. There's anything unsafe, then you don't get registered. So we've got to learn to use our new sciences in terms of physiology, biomarkers, so that we don't have to wait 25 years to see that we've got demonstrable longevity, and therefore this is a safe and efficacious product. So we have to look at our regulatory environment. We've seen the UK government respond well on the patent box, which if you want to commercialise the UK patent, you're taxed at 10%. And we now have the lowest corporation tax by 2015 at 20% for the Western world. So if you have the desire to create wealth, then you know in the United Kingdom you have a very big incentive in terms of the taxation you have to pay. Our public sector play a key role in catalysing the economic benefits of our investment in academic science. They have to look at the use of land, they have to look at where the housing is available, they have to look at the transport and the education. There's a great plan to increase the frequency of trains between here and Cambridge, between London and Cambridge, and Transport for London is going to put in 200 million. There's a great plan for opening up the Lee Valley so we get more housing available, because we're critically short of housing in London. We don't at the moment have great plans to put aspirational schools into Haringey, and I don't believe we're necessarily going to make that a great home for researchers unless they feel they can send their kids to aspirational schools. But what's exciting is that the local authorities are now talking about this challenge. And finally, the private sector, if you're going to move down the idea of really impacting in healthcare through seeing not only your basic research, but the applied research take hold in terms of industrial products, we need the venture capital. And in the last few days, I've been very pleased to see a change in the approach of venture capital to the United Kingdom. I have a dinner at Cambridge tomorrow night to address them, and there's a great deal of an increased excitement that we actually have the relevant skills here that can do more to innovate. So back to culture, we have to ensure that academic and industrial sciences are happy bedfellows. I would do much to persuade you to establish an entrepreneurial culture within the university. We have MedCity, which Boris Johnson has now launched. There's a desire that we encourage entrepreneurism and give people the self-belief that they can innovate. Our challenge for interdisciplinary research is wider than it's ever been. And as I've said, I don't believe that many companies can afford today the level of skills. And I used to have a very large company. I had 48,000 people. But could I get the skills that I wanted in basic maths and basic physics? Not always. And I had to search those out from academia. So I think that it's for universities to understand that their role is to be there both for the excellence for teaching of research, but also as knowledge hubs, and to have the ability to combine the physical and biological sciences informed by the humanities that give us the chance to embrace technology in the service of mankind. To finish with, let me just tell you why I'm excited. And I've always been an enthusiast, but I've learned through 35 years of leading companies that getting your timing right is key. In the last 2 weeks at Wellcome, we had 2 spin-outs from Sanger. They both cost large amounts of money. One was to get into ulcerative colitis. We've attracted £18 million of additional research, which will take it through to clinical evaluation. And then in another research we funded, which was the humanization of the mouse model, then we found that an extraordinary sum of over $60 million has come in for the next funding round. In the last few weeks, I've seen some extraordinary technology development which is being supported, and I call these light bulb moments. In studying the foot and mouth disease virus, the Diamond Accelerator at Harwell, the exact shape of the virus of BP1 has been identified, and the molecular biologists managed to express a protein capsid which gives you full immunological response. So rather than injecting a killed virus into the cattle to prevent them having foot and mouth disease, we're now mimicking the immune system with just a protein shell, and that's given full immunological cover. And one hopes we can use that around the world for all foot and mouth disease, up the protein content and the milk content that comes out of the agrarian world worldwide. It also, the foot and mouth is close to the polio virus, and it's also close to the flu virus. And if we get what's called cross-protection in that area, that would be a great way of mankind dealing with zoonotic outbreaks like avian flu, which threaten us a great deal. And it's interesting to remember that the Spanish flu after the First World War killed more people than the First World War. So we shouldn't forget what zoonotic outbreaks can do to us. In gene therapy, we've seen this remarkable double-blind trial where you inject a single gene that's missing from the genetic inheritance of the individual. They have night blindness, which goes on to full blindness, you can use a modified virus, put the gene cassette that's missing, inject it into one eye, and the proof is there that eye gets sight back, and the one you didn't inject is still without sight. So gene therapy, after 30 years of being looked at, is for real. 30 years of looking at how you modify your own T cells to defend the body against cancer. It looks like a watershed. There's been some manipulation of those T cells, which are being manipulated outside the body, reintroduced, and certainly in blood cancers and hematological cancers, the results are outstanding. All of those extraordinary results have been invested in, and so they're now underpinned by major investment to see them not only developed clinically in the UK, but also the manufacturing base here. So, I'm thrilled by where Mary's is going. I'm thrilled to be asked to come and address you today, and I'm thrilled with Simon's leadership. And I'd just say to you that it's our job to, as managers in this world, to understand how we deliver the ecosystem that allows us to improve the quality of life, embrace personalised medicine, and at the same time pass the benefits on in terms of economic impact. And I believe that there is an academic genius in the United Kingdom, and we can demonstrate unquestionably around the world that we are a major contributor to the advancement of humankind around the world. So, good luck to Queen Mary's. I would personally totally endorse where you are going. Thank you very much.